With the rise of XML as a format for exchanging data, there are also a handful of database management systems oriented specifically around using XML as their internal structure rather than tables of columns and rows. If you haven't delved into the world of XML much, the next 2 minutes might be a whirl of jargon. That's okay. This is really targeted at those who know they have to deal with a lot of XML or are worried they might. So XML-specific database systems include BaseX, Sedna, and Exist. These are all open source. They store XML data directly, large amounts of XML documents using the nested tree structure of XML. So you not only store XML directly, you use XML languages, typically XQuery, to query that data rather than using SQL. Now, these are for quite specific uses rather than the general use of relational database systems, so we're not going to be spending much time on these other than just making sure you're aware of their existence. If XML is naturally your only kind of data, they are worth looking at. If, however, what you have is some XML, there's nothing that stops you from just storing XML in a regular relational database table. It is, after all, just text. And these days, it's very common to see XML as a specific column data type for a regular relational database. SQL Server, Oracle, and DB2 all support XML as a column type, and with other database systems, you can just store it as text. The benefit of having a specific XML type is usually that the database will support using XQuery to manipulate that particular column instead of just SQL. So we can store XML data directly as a column value and either use SQL to work with it or XQuery. But enough, moving on. Object-oriented databases. Like the previous section, the next 2 minutes will mainly benefit those who know a little about object orientation. One of the downsides with relational database management systems came with the rise of object-oriented languages in the 80s and 90s, like C++, Java, C#, and so on. Because the objects we would generate in software in those languages don't necessarily map exactly to rows in a database table. They're more complex than that. So there have been object-oriented database management systems over the years, object databases or OODBMS, that tried to fix this. Things like ObjectivityDB, VelocityDB, and Versant. But like XML-based databases, they never reached the popularity level of conventional relational database systems. They did become popular, but mainly in niche areas like engineering or physics, not in general use. And like XML database systems, we're not working with them here, just making sure you're aware of their existence. But here's the thing. Relational databases are still enormously popular with object-oriented languages. Yes, the problem does exist that software objects don't always match one-on-one with rows in a table. But what's very popular is to use an ORM framework, Object Relational Mapping Software. This is a software framework that helps us map from objects in an object-oriented language to regular relational database tables and back again without really thinking very much about that mapping. And these frameworks include Hibernate in Java, the Core Data Framework for Objective-C, the Active Record Library in Ruby, and so on. These are always very specific to the language that you're working in, so they're out with the scope of a course like this one. In fact, for this is all I'm saying on these topics. Neither XML nor object databases became anywhere near as popular as some people expected. In fact, the most impactful developments in database technology came with the rise of what are called the NoSQL databases, and we'll talk about those next.